All right, let's get right into it. Today, we're talking about how hackers take a bunch of stolen, scrambled data and somehow turn it into your actual passwords.
You know, you see these headlines constantly. Millions of accounts breached. But here's the thing. When a website gets hacked, the attackers don't usually get your plain text password. They get something called a hash. So that's the real mystery, right? How do they crack that code?
A hash is essentially a one-way street. It's like a unique digital fingerprint of your password. You can't just reverse it to see the original. So if it's supposed to be uncrackable, what's the trick?
Well, the answer is almost disappointingly simple. They guess. But we're not talking about one person typing at a keyboard. We're talking about immense computing power, making millions, sometimes billions of guesses every single second. The most basic way they do this is called a brute force attack. And honestly, it's just what it sounds like, trying every possible combination of letters, numbers, and symbols until something sticks.
A specialized program just starts guessing. It takes a guess, hashes it, and then compares that hash to the one in the stolen database. If it doesn't match, no problem. It just moves on to the very next possibility, over and over and over again.
So, the computer might start with something simple, like, it checks the hash, sees it's not a match.
So it tries the very next one in the sequence. B. Still no match. It just keeps on chugging.
And on it goes. Now, as you can probably guess, this method is thorough, but it can take a ridiculously long time. So attackers had to get smarter and find faster ways to guess.
And this is where things get more clever. Instead of just trying random strings of characters, hackers started focusing on what we humans actually do. They started exploiting our predictability.
This leads us to the dictionary attack. I mean, why bother trying QWZX when you can just try actual words like monkey or sunshine? Attackers use huge lists of common words, and even more powerfully, lists of passwords that have been leaked in other data breaches.
And this is the scary part. If your password is on one of these common lists, it's not a question of if it'll be cracked. It's a question of how many milliseconds it's going to take. These are basically free passes for an attacker. Okay, so you're thinking, I'm not going to use password. But what if you just, add a number at the end? Yeah, hackers are already way ahead of you. This is what's called a variation attack. Their programs automatically take every single word from those dictionary lists and start applying common rules, like adding a 1, adding a 1, 2, 3, capitalizing the first letter, or swapping an E for a 3. This just massively increases their chances of getting a hit. Now, to make things even faster, hackers developed a seriously powerful tool. But fortunately for us, modern systems have a pretty brilliant defense against it.
This tool is called a rainbow table. So instead of guessing and hashing every single time, hackers did the work ahead of time. They pre-calculated the hashes for millions of common passwords and stored them in a giant table. It's kind of like having an answer key for a test. They just look up the hash they stole and instantly find the matching password.
That sounds really bad, right? I mean, if they already have an answer key, how can any password be safe? Well, the defense is a really clever trick called salting. And this is how it works. Before a system hashes your password, it adds a little piece of random unique data to it. That's the salt. So now, even if you and I both use the exact same password, say password 123, the random salt added to each of ours means the final hashes will be completely different. And just like that, those pre-computed rainbow tables are completely useless.
Now, salting is an awesome defense, but it's not magic. The system can only protect a password so much. If your actual password is weak, it can still be guessed eventually. Really, the final and most important line of defense is you. So, what does a strong password actually look like? Security experts all agree on 3 key things. It needs to be long. The longer it is, the more combinations a hacker has to try. It needs to be random, so it won't show up in any dictionary, and, this is so important, it has to be unique for every single one of your accounts. Because really, when it all comes down to it, that's the whole game. The goal isn't to outsmart a supercomputer. It's just to create something that no person and no program could ever possibly predict.